This is the second recording on a series of screencasts on air pollution. And we're looking at the major air pollutants, and this time we're going through the table looking at the impact particularly on human health and the environment. So the one on the top here is sulfur dioxide, and sulfur dioxide is a respiratory irritant. That means the respiratory system consists of your nose and your lungs and the parts in between. And people who have lung conditions such as asthma, the linings of their various cells of these organs gets irritated by the sulfur dioxide and makes their symptoms worse. Sulfur dioxide gas can also harm plants. Plant leaves have at the bottom of them little openings called stomates. And these stomates are where air exchange occurs. So they bring in the carbon dioxide that they need for photosynthesis, and they release the oxygen that's so important to other living things, and they also release water through the stomates. So in a sense, it's their equivalent of a respiratory system, and it can be harmed by sulfur dioxide gas. So last, sulfur dioxide gas transforms to sulfuric acid, and as an acid it's very harmful to aquatic life, particularly fish, and it can also be harmful to some vegetation. The second air pollutant on the list here is nitrogen oxides, and again we begin with the words respiratory irritant. In this case, it increases human susceptibility to respiratory infection, so it increases the likelihood a person would come down with something like pneumonia. In addition, nitrogen oxides are ozone precursors. We'll talk about ozone in a few minutes, but it leads to smog. And also it converts to nitric acid in the atmosphere, and again, that's harmful to aquatic life and some vegetation. So the nitrogen oxides and the sulfur dioxide have very similar effects or impacts on humans and on ecosystems. Moving down to the third one, which is carbon monoxide. That's more of a problem for humans, particularly in our homes. So normally there is on your red blood cells a chemical called hemoglobin, to which the oxygen binds and it travels around the body, oxygenating your cells. Unfortunately, carbon monoxide binds to hemoglobin even more readily than oxygen does. So if you're surrounded by carbon monoxide, the carbon monoxide binds up the hemoglobin and the oxygen can't combine with it, and therefore your body doesn't get enough oxygen. At low levels, that would just cause minor symptoms like headaches, and then as the levels increase, people become sleepy or confused, and eventually it can kill people. So carbon monoxide is very important to be careful about in a home. People should get carbon monoxide detectors. If you have a multi-story home, it's a good idea to have one for each level of your home. They are a little bit expensive, I think maybe $25 or so each, but oftentimes the fire department or other agencies will provide them free of charge for those who need them. They would much rather you have yourself protected than have to respond to such a call. Okay, next on the list is particulate matter. And again, it can exacerbate respiratory symptoms, respiratory diseases, reduce lung function, and also exacerbate cardiovascular disease. This can even lead to premature death. Environmentally, it reduces visibility and contributes to haze and smog. The next one on the list is particularly important in terms of its impact on humans, and that's lead. Lead impairs the central nervous system. That means the brain and the spinal cord, particularly the brain of developing children. Children's brains are developing, so it impairs them in particular. And this can happen at even relatively low concentrations. So the story of lead in the United States is quite a disturbing one. When cars were first invented in the 1920s, the manufacturers decided that by adding lead to gasoline, it would reduce knocking and improve efficiency of the car and so forth. And that continued to happen all the way through the 1950s. So the car and gasoline industries repeatedly said that there was absolutely nothing wrong with lead, that it did not have these terrible health effects. But in reality, they knew that wasn't the case. Some of their employees, large numbers of employees that worked with the lead, became crazy, mentally ill, seeing hallucinations and things like that, and some of them even died. So this went on for a very long time, and it also happened with lead paint impairing children. Children would eat the peeling paint and then have high levels of lead in their body, and that caused them to have a lower IQ. So it had educational impacts, it had behavioral impacts on the children as well, and it also had medical impacts on the children. And eventually, there was an end to this nightmare, and lead was no longer allowed to be in paint or in gasoline. So I've attached to our Moodle shell an article about lead and gasoline and its history. I did not attach one about human health and the paint, but if you're interested, I'd be happy to tell you more about that situation. Okay, moving on to the rest of the table here, we have ozone next. And again, ozone reduces lung function and exacerbates respiratory symptoms. And one of your assignments on Moodle is to watch a video, which includes a clip on the effect of ozone on lung function. Also, ozone is dangerous to plant surfaces and damages materials such as rubber and plastic. So now to the other air pollutants. The volatile organic compounds are a precursor to ozone formation, and as you'll see, ozone can be cause respiratory illness when it's in the troposphere. The next one, mercury. Similar to lead, it impairs the central nervous system, and not only that, it bioaccumulates in the food chain. So when we discuss the topic of human health, we're going to look at mercury as a case study, because in Japan, there was some mercury produced as a result of some industrial operations, and that got into the water of Minamata Bay, and it moved up the food chain of fish and then up to humans, and cats were also affected, and it had very serious health consequences for both. Okay, next on the list, carbon dioxide. Carbon dioxide, CO2, affects our climate, and it alters ecosystems by increasing greenhouse gas concentrations. We'll look more at that in a subsequent chapter, so I'll just limit it to that for now. So that concludes our list of major air pollutants, their sources, and their impact on human health and ecosystems. Notice that a lot of these had to do with combustion of materials, usually for energy, for heat, often fossil fuels, but also could include things like wood and biomass. And the impacts could range on human systems from respiratory illnesses, impaired central nervous system, which includes your brain, and also other serious nervous system impacts. And it can also alter ecosystem by being too acidic or by bioaccumulating in the ecosystem and making organisms sick or interfering with things like gas exchange in plants. So now we'll go on and look at some of the other forms of air pollutants and things like how they're affected by temperature, size, and so forth. So first we're going to look at particulate matter. And as you can see from the picture, one of the sources of particulate matter is road dust. Many roads throughout the world are not paved, and as a vehicle goes down them, especially things like trucks, dust is produced. Vehicle exhaust also produces particulate matter. Even with the catalytic converters that we now have, there still is some exhaust which is made of particulates. Another major source of particulate matter are power plants that release smoke after burning fossil fuels, particularly things like coal. And as noted in your textbook, you can have natural sources of particulate matter, such as wood burning and volcanoes, though often the wood burning is not just from a natural fire, it's often from human-caused or on-purpose fires. So one of the important factors with particulate matter is that size matters. So the tinier a particulate matter is, so PM 2.5, meaning it's a substance which is less than 2.5 micrometers or micrometers in size, is much smaller than one that's less than 10 micrometers in size. And if you have a very large particulate matter, like 100 micrometers, it won't go into your nose. Your nose will filter it out, and so you won't breathe it in. As you move down to this PM10, you will have some of this getting into your lungs, and that can cause problems for your respiratory system that we've mentioned before, irritation, or even scarring. As you get down to the very tiniest particles, like the 2.5 micrometer and less, then these particles can get into your tiniest pockets of your lungs, and that's where the air exchange occurs, and that is very problematic to human health. So the smaller the particle size, the worse the particulate matter is for human health. Okay, next we'll look at some categories of air pollutants. There are primary and secondary air pollutants. Primary air pollutants are compounds that come directly out of a source, such as a smokestack, the exhaust pipe of a car or truck, or from a natural emission source like a volcano. That concludes the second screencast on pollutants, and the third screencast will move on to look at the sources of these air pollutants.